Hello everyone. Let us see the solutions for Government Polytechnic Lecturer examination conducted by Andhra Pradesh Public Service Commission for Electronics and Communication Engineering. Previous question paper held on 2013. First question. Any two-port network having 3 dB power loss will provide. Correct option is 2. The output power which is 0 half of the input power. So given loss is 3 dB. Loss is 3 dB. So 10 log L is 3 dB. Full loss L is 10 power 3 by 10, that is 0.3. Its value is approximately 2. So loss is input power by output power. So its value is 2. So output power is half of input power. Any two-port network having 3 dB loss, any two-port network having 3 dB loss will provide an output power which is one half of the input power. Hence, 3 dB frequencies are called half power frequencies because these are the frequencies at which power is half of the maximum value. Similarly, a two-port network having for 3 dB output power is half of input power. Similarly, for a two-port network having 6 dB loss will provide an output power of one quarter of input power. This 3 dB frequencies is also called half power frequencies because the power is half of the maximum power. Next question. Correct option is 2. Next question. For a given network, the incident matrix is given as. This is the incident matrix given with 6 branches. 1, 2, 3, 4, 5, 6 are the 6 branches and nodes A, B, C, D. A, B, C. These are the nodes given and these are the branches. 1, 2, 3, 4, 5, 6. And the question they ask to find number of parallel branches. The parallel branches are. So we know that the property of incident matrix is each column of an incidence matrix contains only one entry of plus 1 and only one entry of minus 1. Every column of incident matrix contains two elements, that is plus 1 and minus 1, one entry of plus 1 and one entry of minus 1, so that sum of elements in any column and sum of elements in each column is always 0, and each row contains plus 1, minus 1 and 0 depending on the orientation of branches with the node. This is the first property. And the second property is in the incident matrix entry is plus 1 if branch is pointing away from the node, entry is minus 1 if branch is pointing towards a node, and entry is 0 if it is not connected to the node. So in this question, as per property 1, in this column plus 1 is minus 1 is missing. So the given matrix is reduced incident matrix. So this is reduced incident matrix. So we need to convert this reduced incident matrix to incident matrix using property 1. So here element missing is minus 1, so that each column contains plus 1, minus 1. Sum of elements in each column is 0. Plus 1 and minus 1, and sum of elements in each column is 0. Next, element missing in column 2 is minus 1, minus 1, 0, 0. In last column, plus 1, minus 1 is present, so the last element is 0. Okay. So here A, B, C, D are the nodes of incident matrix. 1, 2, 3, 4, 5, 6 are the branches. Now for this incident matrix, graph will be like this. So this is a graph for the incident matrix. So the given circuit has no parallel branches. So the condition for parallel branches is the branches in incident matrix are said to be parallel if columns of incident matrix with unit entries in two identical rows corresponding to branches with same ends. So the branches of incident matrix are said to be parallel if columns of incident matrix with unit entries in two identical rows corresponding to branches with same end nodes. So this condition of parallel branches is not satisfied by this incident matrix. So here the branches parallel are no option is correct. So there is no correct option for this question. No correct option. Let us see one more example related to parallel branches. So this is the example. Given matrix is incident matrix. So as per the property 1, so in column 1, 1 these are the branches, 6 branches and 3 nodes. So this matrix is reduced incident matrix. We need to convert this reduced incident matrix to incident matrix. So minus 1 0 0 1 0 0 0 minus 1. So how to convert this reduced incident matrix to incident matrix is using property 1. Each column contains two elements, one entry of plus 1 and one entry of minus 1, so that the sum of elements in each column is 0. Here plus 1 is missing. Here plus 1 is missing. Here plus 1 is missing. Here it contains both plus 1 and minus 1, so 0. So 0 here, and here it is plus 1. Now see, from the this incident matrix A, column 3, so this column and column 6 same elements. So column 3 and column 6 has same elements, 0 0 minus 1 plus 1 0 0 minus 1 and plus 1. So this is 3 and 6. So now the branch 3, so from this incident matrix this is a corresponding, for this incident matrix this is a corresponding graph. So from this incident matrix or corresponding graph we can say that branch 3 and branch 6 are parallel, because this parallel condition is satisfied by this example incident matrix. So as per the question, there is no correct option. Next question. A connected graph of n nodes greater than 2 has at most one branch directly connecting any pair of nodes, the graph of the network. So correct option is 1. Must have at least n branches for one or more closed path to exist. A graph is said to be connected if there exists at least one path between any two vertices or nodes of the network. On the other hand, if a graph contains at least two separate parts, then it is said to be unconnected graph. So we know the definitions of connected graphs and unconnected graphs. In an connected network or connected graph of n greater than two nodes have at most one branch directly connecting any pair of nodes. The graph of network must have at least n branches for one or more closed path to exist. Next question. A capacitor with capacitance C and initial voltage Vc of 0 is given below. Then impedance diagram, admittance diagrams are given. Then we need to find which is the correct option. So the time domain representation of capacitance current in the capacitor is I of t is equal to C dV by dt. Then voltage V of t is 1 by C integral minus infinity to t I of t dt. So that is equal to Vc of 0 initial voltage plus 1 by C integral 0 to t I of t dt. So in S domain, the admittance diagram for capacitor C, so S domain, that is Laplace domain, admittance diagram for capacitor C with initial voltage, for capacitance C with initial voltage Vc of 0 plus is, it is given by like this, 1 by SC, SC, this is a volt, C Vc of 0, this is a current I of S, this is voltage source V of S. So the correct option is 1. Similarly, the impedance diagram for capacitor C with initial voltage Vc of 0 plus is this is the impedance diagram. Next question. In a network as shown in the figure, the switch S is closed at t is equal to 0 with capacitor uncharged. The value of di by dt at t is equal to 0 plus will be. So given this network consists of resistor and capacitor, hence it is a RC network. So the time constant of this network is tau is equal to RC, where R is 1 kilo ohm, and capacitance is 1 microfarad. So its value is 10 power minus 3. So 1 millisecond is the time period of the given circuit. So the equivalent circuit. So generally the equivalent circuit for capacitor C, which is initially uncharged at t is equal to 0 plus, is short circuited. So t is equal to 0 plus, the capacitor is short circuited at t tends to infinity. So this is the initial state, and final state capacitor acts as a open circuit. It is short circuit at t is equal to 0 plus and t tends to infinity. That is at steady state capacitor acts as a open circuit. So the time constant of circuit is 1 millisecond. Tau is equal to 1 millisecond. So when the switch is closed at t is equal to 0, the equivalent circuit is given as like this. When switch is closed at t is equal to 0, this capacitor acts as a short circuit. Here it is short circuit, only resistance R and voltage source V is given. So voltage source is 100 volts. Now the current flowing, current I is equal to V by R, and its value is 100 volts by 1 kilo ohm, that is 1000. So current is 100 milliamperes. Now initial current is 0. Initial current is 100 milliamperes. So this is the initial current. Initial current at t calculated at t is equal to 0 plus. At t is equal to 0 plus, the capacitor acts as a short circuit, and this is the equivalent diagram. At t is equal to infinity, at steady state, at t tends to infinity, capacitor is open circuit. So capacitor is open circuit. Now zero current flows. Here current I final. So final current is 0. So this is the initial current and this is the final current. Let it be I1 and let it be IF, or II initial current, IF is a final current. So final current is 0 and initial current is 100 milliamperes. So the expression for current in RC series circuit, I of t is equal to I final minus of I initial into e power minus t by tau, where tau is a time constant. Time constant for RC circuit is RC. So I final is 0. Final value of current is 0 because in steady state or t tends to infinity, the capacitor acts as a open circuit. So final current is 0 minus I initial. Initial current is 100 milliamperes into e power minus t by. So for time being, let it be tau only. So then di by dt. In the question they ask to find the value of di by dt at t is equal to 0 plus. So di by dt is 100 milliampere, 100 into 10 power minus 3 d by dt of, so in differentiation, d by dt of e power minus ax is minus a e power minus ax. So this is the value of differentiation. So once we will get differentiation, so its value is minus 1 by tau e power minus t by tau. So its value is minus 100 e power t by 1 millisecond, that is 10 power minus 3. So they have given di by dt at t is equal to 0 plus. So di by dt at t is equal to 0 plus second. So replace t with 0. So that is minus 100 e power 0 by 1 milli. E power 0 is 1. So its value is 100 ampere per second. Di by dt is current to second minus 100 ampere per second. So the correct option is 3. Next question. For a series RLC circuit shown below, RMS voltage across the capacitor is. So given this is a series RLC circuit, let I be the current flowing through the series RLC circuit. XL is inductive reactance, XC is capacitive reactance. The value of XL and XC is same. The value of inductive reactance is same as capacitive reactance. So that means the circuit is in resonance condition. So once a circuit is in resonance condition, the total impedance Z is R in series RLC circuit. So therefore the total current I is equal to V by Z. So it is V by R. So voltage is 200 volts, 200 volts RMS, and the resistance is 10 ohm. So the current in the circuit is 20 amperes. At resonance, voltage across the capacitor is, so voltage across the capacitor V is equal to quality factor into voltage, total voltage at an angle of minus 90 degrees. So the quality of the circuit, when for this series RLC circuit, quality factor Q is equal to XL by R. So XL or XL is 20 and resistance is 10. The quality factor of the circuit is 2. So current is known, quality factor is known, quality factor is 2, and the voltage given is 200 volts supply voltage at an angle of minus 90 degrees. So its value is 400 at an angle minus 90. Correct option is 3. Similarly, voltage across the inductor is given as quality factor supply voltage at an angle of plus 90 degrees. So 200 at an angle of plus 90. So its value is 400 at an angle of 90 degrees. So voltage across the inductor, and voltage across the capacitor is, sorry, voltage across the similarly voltage across the resistor is I into R. That is the source voltage. So these are the voltage across capacitor, inductor, and resistor. Quality factor. So correct option is 3. Next question. Fourier transform of a periodic signal. So Fourier transform of a periodic signal consists of train of impulses in frequency domain occurring at harmonically related frequencies. Fourier transform of a periodic signal consists of train of impulses in frequency domain occurring at harmonically related frequencies. So the correct option is 1. Similarly, Fourier transform of periodic sequence consists of periodic impulse train with values proportional to discrete Fourier series coefficient. For Fourier transform of a periodic signal consists of train of impulses in frequency domain occurring at harmonically related frequencies. The Fourier transform of periodic sequence, here it is signal, for a periodic sequence consists of periodic impulse train with values proportional to discrete Fourier series coefficient. So let us see some important points. So periodic sequence consists of, so this point is done, and for Fourier transform it is continuous and aperiodic. Discrete time Fourier transform is continuous and periodic. Given next question. If the Fourier transform of signal x of t is given below, for a signal x of t, for a signal small x of t, so its Fourier transform is capital X of f. This is a Fourier transform of small x of t, and it is given below. And the signal y of t is x of t cos 2t. This is a signal y of t. And the Fourier transform of x of t cos 2t, Fourier transform of y of t, so that is Fourier transform of small x of t cos 2t. So it is given as 1 by 2 capital X of f minus 2 plus capital X of f plus 2. So this is a Fourier transform of small y of t, that is capital Y of f in frequency domain. Now this is a signal given. So this signal has to be shift right by 2 units. So this is shifting in right and this is shift left by 2 units. Here it is a delay in signal. The signal is delayed by 2 units and signal is advanced by 2 units. In this case, f of x of f plus 2 is left shift or signal advance. F of f minus 2 is right shift or delay in signal. So, so this is x of f minus 2 using time shifting property of the signal x of f plus 2. Here amplitude is 1 and amplitude is 1. For y of t signal, so amplitude is half of this amplitude, so that is 1 by 2 and the signal is shifted by 2 units here, delayed by 2 units, and this is x of so 1 3, this is frequency axis, 0 minus 1 and minus 3. So this is a resultant signal x of f minus 2, x of f plus 2, advance signal, delay signal, shift right or shift in left. So correct option is 2. Next question. The practical bandwidth of narrowband FM signal. So given it is a narrowband FM signal, the practical bandwidth is same as the bandwidth of amplitude modulated signal. So that is, so bandwidth of this narrowband FM is 2 FM, where FM is the highest frequency component of the message signal. Similarly, for wideband FM using Carson rule, the bandwidth is given as bandwidth is equal to 2 into beta plus 1 FM. So where beta is modulation index of frequency modulated signal, it is a ratio of frequency deviation to delta f by fm, frequency modulation to message signal highest frequency component, bandwidth of narrowband signal and bandwidth of wideband signal. So correct option is 2. Next question. Find the Norton equivalent of a circuit shown below. So this is a circuit given. For calculating the Norton resistance, all the independent voltage sources are to be short circuited and independent current sources are open circuited. Voltage sources are short circuited and independent current sources are open circuited and dependent sources remain as it is. But for this circuit, there are no dependent sources. Only one independent voltage sources is given. Only one independent voltage source is given. So these independent voltage sources are short circuited. So it is short circuited here and we need to calculate the Norton resistance or Thevenin's or RTH, that is Rn or RTH. So these two so when we look into the terminals A and B, so this resistor and this resistor are in parallel combination. When two resistors of same value are in parallel combination, then its resistance is R by N. So that is R by 2, resistance is 2 and 2 by 2, its value is 1, and this 2 plus 2, these two are parallel, which is in series with, so 2 ohm resistance parallel to 2 ohm resistance, which is in series with 4 by ohm. So this is a Norton resistance or Thevenin resistance for this circuit, and its value is 9 by 5, 1.8 ohms. So approximately we can take it as 2 ohms as per the options. So 2 ohms in option 1 and option 2. Next, Norton's current, it is a short circuit current So Norton current is the short circuit current between the terminals A and B. So Norton current is the short circuit current IN between the terminals A and B. So how to calculate this Norton current? So in this case, apply nodal analysis where V is a node voltage. So apply nodal analysis and V is a node voltage. So from this nodal equation is nodal analysis. Node equation is V minus 2 by 2. So V minus the voltage here is 2 volts. So this V minus 2 by 2 plus V by 2. So here it is V by 2 plus V by 4 by ohm is equal to 0. On calculation, voltage V is 4 by 9. 4 by 9. So this node voltage is 4 by 9 volts. So from this current IN or short circuit current ISC, Norton current IN is V by this 4 by ohm resistor. So its value is 0.55 ampere. So the correct option is 2. So that value of 2 by 5 is 0.4. So take it as 20 by 5 is 4, 0.4. So the 0.4 is close to 0.55. Correct option is 2. Nearest option is 2. So this is short circuit current calculated by using nodal analysis on Thevenin's resistance. So from this circuit Thevenin's resistance, from this circuit short circuit current. Oh, next question. In the circuit shown, the value of current I is. So this is a circuit given. We need to calculate the value of current. Again apply nodal analysis for the circuit. Let V1 be the node voltage at this point and V2 be the node voltage. Let V1 and V2 are the node voltages. So by nodal analysis, V1 by 4 plus V1 minus V2 by 2 minus 10. V1 minus V2 by 2 minus 10. So this is equation 1. Next equation 2 is V2 by 8 plus V2 minus V1 V2 minus V1 by 28 plus 5 is equal to 0. So on solving these two equations, this equation 1 and equation 2, we will get V1 is equal to 32 volts and V2 is minus 24 volts. Now the current I is expression for current is flowing in this direction, so V1 is greater than V1 minus V2 by 28 ohms. So V1 is 32 minus of minus 24 by 28. So 56 by 28, its value is 2 amperes. So this is first method by using nodal analysis. So method 1. So let us see another method how to calculate the value of current. So simple by using source transformation technique. Source transformation techniques means a current source with parallel resistance can be converted to a voltage source with series resistor. Voltage source with series resistor. So similarly here also a current source with parallel resistance can be converted to voltage source with the series resistor. So here, so current source with parallel resistance is converted to voltage source with series resistor. So the corresponding equivalent circuit is, so 10 into 40 is 40 volts plus or minus 40 volts and the series resistance is 4 ohm. Next, 28 ohm resistor, again 8 ohm resistor, minus plus, the current direction is downwards, so minus plus 40 volts. Now apply KCL in the loop. So current I, apply KVL in the loop, so that is 40 volts plus 40 volts minus 4I minus 28I minus 8I, so it is 0. So its value is 80 volts is equal to 40 times of current. Total resistance is now voltage, now current, sorry, 40. So this is 40. So 80 is equal to 40 times of current. Now current I is 80 by 40, so its value is 2 amperes. So one is source, by using source initially by source transformation technique, answer is 2 amperes, or by using directly nodal analysis, the answer is 2 amperes. So current is 2 amperes, correct option is 2. Next question. The circuit shown in the figure has been a steady state when switch S is opened and the current I after the switch is opened is given as, given the circuit is in steady state before the switch S is opened. So this is given. Next, in steady state, inductor acts as short circuit. So this inductor acts as steady state at t tends to infinity. Inductor acts as short circuit at initial state. It acts as a open circuit. Open circuit. So the equivalent circuit in steady state is, so inductor is short circuited. This is a voltage source V, resistance R1, resistance R2, inductor is short circuited. So the current through, because this path is short circuited, now current flowing through R2 is 0, resistance R2 is 0, because current always chooses to flow in least resistance path. Now total current I, so total current I is equal to V by R equivalent, so it is V by R1. So this total current I, V by R1. Now this current is V by R1. Now when next condition, when switch S is open, when switch S is open, the equivalent circuit is like this. You can take this current as I1. Here it is I1. This is a current I as per the circuit diagram, and this is inductor. The equivalent circuit will be, when switch S is open, we can remove this resistance R1. Here it is open circuited. There is no use of resistance R1. Resistance R2, inductor. This is I0. When switch is open, this voltage source is disconnected from the circuit. Now inductor, which is initially stored, now starts discharging. So this is inductance L. Now the time, this is RL circuit. For this RL circuit, time constant tau is L by R. The value of time constant is L by R, that is L by R2 second. And total current for series RL circuit, the total current I of t is I final minus I final minus I initial e power minus t by tau, minus t by tau. Now the initial value of current is V by R1, which is calculated previously, and the final value of current is 0. Final value of current is 0. The total current I of t is V by R1 e power minus t by tau, that is L by R2 minus t by tau, that is L by R2, or V by R1 e power minus R2 t by L. This is the current in this circuit, expression for the current in the given RL circuit. V by R1 e power minus R2 into t by L. So correct option is second option. Next question. The time rate of change of voltage applied across the capacitor is 1 microfarad is 2 volts per second. This means the current flowing through the capacitor is, so given rate of change of voltage dV by dt 2 volts per second and capacitance C is equal to 1 microfarad. Now the current flowing through the capacitor is C dV by dt. So that is 1 micro 10 power minus 6 and 2 volts per second. So its value, the current is 2 into 10 power minus 6, 2 micro ampere or 2 into 10 power minus 6. Correct option is 1. Next question. Total capacitance across the points 1 and 2 in the circuit given is, when two capacitors are connected in parallel. So equivalent capacitance is C1 plus C2. So that is C1 C2. Equivalent capacitance is C1 plus C2. When two capacitors are connected in parallel, equivalent capacitance is C1 plus C2. When two capacitors are connected in series, then equivalent capacitance is C1 C2 by C1 plus C2. So using this formula, now here these two are connected in parallel. Now its equivalent value is 2 microfarad. Similarly, this it is connected in parallel. Equivalent is 2 microfarad. So 2 microfarad, 2 microfarad. Now these 2 microfarad and 1 microfarad are connected in series. So this equivalent is 2 into 1 by 2 plus 1. So that is 2 by 3. So equivalent circuit is 2 microfarad connected in parallel with 2 by 3 microfarad. Again these two are in parallel. So final equivalent capacitance is 2 micro plus 2 by 3, 0.66. So that is 2.66 microfarad. So correct option is 4. Next question. Which of the following represents the total number of trees in a given figure? So, so one method is directly obtaining the or drawing the total number of trees from the graph, or we can calculate mathematically by using a formula. The total number of trees is n into n power minus 2 for a fully connected graph, where n is the number of nodes. But this graph is not a fully connected graph. So for that graph is not fully connected, then expression for number of trees is determinant of A transpose. So where A is reduced incident matrix. Initially, for this graph, we need to write the incident matrix. From this incident matrix, we used to calculate reduced incident matrix. Step 1 is, for the given graph, we need to write incident matrix. From the incident matrix, we need to find out the reduced incident matrix. That is step 2. In step 3, so transpose of reduced incident matrix, and step 4 is determinant of these two. Incident matrix and reduced incident matrix determinant will give total number of trees for a non fully connected, not a fully connected graph. So for this case, there are 4 nodes and the incident matrix is like this: 1 0 0 minus 1, because from 1 and 4 for branch A, from 1 and 4, from node 1 and node 4 there is a connection. From node 1 it is pointing away from node 4, so it is plus 1, pointing towards, branch is pointing towards at node 4, it is minus 1. So likewise for branch B, it is connected between node 1 and node 2, and it is away from node 1, so plus 1, and oriented towards node 2, minus 1, and there is no connection between node 3 and node 4, so 0 0. Similarly for branch C, 0 1 0 minus 1. For branch D, 0 minus 1 1 0. For branch E, 0 0 1 minus 1. So this is the incident matrix. For incident matrix, remove the last row, it will become reduced incident matrix. So one, this node 4 is taken as reference node. So reduced incident matrix now consists of 3 nodes and same number of branches. So its reduced incident matrix is 1 1 0 0 0 0 minus 1 1 minus 1 0 0 0 0 1 and 1. This is a reduced incident matrix. Now let us suppose A dash, the transpose of A dash, transpose of A dash, transpose of reduced incident matrix is rows will become columns and columns will become rows. First row will enter in first columns: double 1 triple 0 0 minus 1 1 minus 1 0 0 0 triple 0 and double 1. Now the determine product of this incident matrix and reduced incident matrix and reduced incident matrix transpose. So it will give an matrix like this: 2 minus 1 0 minus 1 3 minus 1 0 minus 1 2. So this is the matrix multiplication of reduced incident matrix A dash and transpose of reduced incident matrix. Next, the determinant, apply determinant for this reduced incident matrix and its transpose. So we will get 8. So that means the number of trees are 8. So the number of trees are 8 for this given graph. Or otherwise, second method is, from the graph we need to draw all the number of trees. So after drawing this is the first one, first, second, third, fourth. After drawing this, we will get total 8 trees for the given graph. So both methods we can follow. So the correct option is 3. So method 1 is, we need to find whether it is fully connected graph or not fully connected graph. If it is fully connected graph, number of trees are n into n power minus 2. If the graph is not fully connected, and this is a method we need to follow. So that is determinant of A transpose, where A is a reduced incident matrix. So first for this graph we need to find the incident matrix. Once it is done, we need to go for the reduced incident matrix, transpose of reduced incident matrix. So this is the transpose in product of incident matrix and reduced incident matrix and its transpose. And finally we need to go for the determinant. The value of determinant is a number of trees for the given graph. Next question: initial value theorem and final value. So this question is related to final value theorem. So if x of t is a Laplace, for x of t, Laplace transform is x of s, Laplace transform is x of s, then final value theorem is limit t tends to infinity x of t, so that is x of infinity is equal to limit s tends to 0 s into x of s. So this is a final value theorem. So similarly, initial value theorem is limit t tends to 0 x of t is equal to x of 0. So its value is limit s tends to infinity, limit s tends to infinity s into x of s. So this is final value theorem and this is initial value theorem. This final value theorem is used to determine the steady state value of system output. So this final value theorem is used to determine the steady state value of system output. Option 2 is the correct one. So final value theorem is used to find final steady state value of time response of a linear system or to find the DC gain Next, initial value theorem is used to determine the starting conditions or initial conditions of the system or initial value of the system. So this initial value theorem is to find the initial value or starting conditions or initial conditions of the system. So correct option is 2. Next question. A step voltage applied to an RLC series circuit having resistance 2 ohm, inductor 1 Henry, capacitance 1 microfarad. The transient current response in the circuit would be. So first is this natural response or transient current response is a solution where there is no external source. So for transient current, for finding the natural response or a transient response, it is a solution where there is no external source. The characteristic equation characteristic equation for this series RLC circuit is not affected by the presence of DC source. In the question they have given unit step function is given. So unit step function is DC voltage source. For obtaining the natural response or transient response in the solution, there should be no external source. So therefore, series RLC circuit is not affected by this characteristic equation is not affected by the presence of DC voltage source. Now the characteristic equation for this is S square plus R by L into S plus 1 by LC is 0. So that is S square plus R by L is 2 by 1, that is 2S, plus 1 by LC 1 by 1 into 1, that is 1, that is equal to 0. Compare with standard second order characteristic. This is a standard second order and this is a characteristic equation obtained for the given series RLC circuit. Now we will calculate what is R by 2L. So resistance by 2L is R is 2, 2 by 2, its value is 1, and 1 by root LC, the value of 1 by root LC, so its value is 1. Now R by 2L is equal to 1 by root LC. So the system is critically damped. The system is critically damped system. Remember, the transient response is independent of input voltage source, independent of magnitude of step voltage. So from this expression given for this characteristic equation, so for overdamped is R by 2L greater than 1 by root LC. For critically damped system, R by 2L is equal to 1 by root LC. For underdamped system, R by 2L less than 1 by root LC. So for this case, R by 2L is 1 by root LC. Therefore, the system is critically damped system. Next question. In the circuit shown figure, the voltage across 2 ohm resistor. So this is to calculate the voltage across 2 ohm resistor. Applied nodal analysis. Let V1 be the node voltage and V2 be the node voltage at node A and node B correspondingly. The node equation. So directly V2 is 3 volts. Apply nodal analysis at node A. So that is V1 by 1 plus V1 minus V2 by 2 minus 6. Entering current is minus 6, it is 0. On calculation, we will get V1 is equal to 5 volts. Therefore, voltage across 2 ohm resistor is V1 minus V2. It is 5 minus 3, so it is 2 volts. Correct option is 2. Next question. In a linear network, the ratio of voltage excitation to current response is unaltered when the position of excitation and response are interchanged. It represents reciprocity theorem. So in a linear, passive, bilateral network, the ratio of response to excitation is constant even if the source and response are interchanged. So that is the definition for reciprocity theorem. Once again, in a linear passive bilateral network, the ratio of response to excitation is constant even if the source and response are interchanged. And this reciprocity theorem is valid only when single independent source is present. Only when single independent voltage source or current source is present. The presence of dependent sources the presence of dependent sources make the network active, hence reciprocity theorem is not applicable. If a network contains more than one voltage source or more than one current source, more than one independent voltage or independent current source, reciprocity theorem is not applicable, and the presence of dependent sources also make the network active, hence reciprocity theorem is not applicable, and it is applicable only for the linear passive bilateral networks. Next, given network, show the parameters h11 and h22. So the given network is a T network. For the given T network, it is easy to calculate the Z parameters. So let's suppose this is a T network given. So this is ZA, sorry, resistance RA, RB, or you can write as ZA only, ZA, ZB, ZC. So this is port 1 and this is port 2. Entering current I1, input voltage V1, entering current I2 and voltage V2. Now total Z parameters. So Z parameters are Z11, Z12, Z21, Z22. So from this Z11 is ZA plus ZC and Z12 is ZC, Z21 is ZC, Z22 is ZB plus ZC. So this is the corresponding open circuit parameters or impedance parameters for the given T network. So for this Z parameters are Z is equal to, so 1 plus 4, 5, 4, 4 and 10. So this is Z11 is 5 and Z12 is 4, Z21 is 4 and Z22 is also is 10. So the relation between H parameters and Z parameters is H11, H12, H21, H22. So the relation is delta Z by H11 is delta Z by Z22. Next H12 is Z12 by Z22. H21 is minus Z21 by Z22 and then 1 by Z22. This is a relation between H parameters and Z parameters. So from this H11 is delta Z by Z22. So modulus of delta Z is 5, 4, 4, 10. So modulus, the value of this delta Z is 34. So from this H11 is 34 by 10. So it is 3.4. Similarly, H11. So similarly, H21, as per the question, H21 is minus Z21 by Z22, that is minus 4 by 10. Its value is minus 0.4. So the correct option is 2. 3.4 and minus 0.4. 2 by 5 is 0.4. Next question. For a two-port network shown, select the correct statement. So this is a given circuit. So with input voltage port 1, input voltage V1 and output voltage and port 2 voltage is V2. Port 1 current will be I1 and port 2 current will be I2. So given for this network, series current I1 is minus I2. This is simply a series element. Current I1 is equal to minus of I2. So impedance parameters, Z parameters or impedance parameters or open circuit parameters are not defined for this network, because if one of the port is open circuited, the other port current will become 0. If I2 is open circuited, I1 is 0. If I2 is open circuited, then current I1 is 0. If input port is open circuited, then current I2 is 0. Open circuited means current I2 is also 0. Next, so when port 2 P2 is open circuited, current in the port 1 is 0. When port 1 is open circuited, current in the second port is 0. Hence, these Z parameters or impedance parameters or open circuit parameters are not defined for this network. So Y parameters for this network is, for this series element, Y parameters is 1 by Z minus 1 by Z minus 1 by Z and 1 by Z. So ABCD parameters can also be defined for this network. So ABCD parameters for this series element is 1 Z 0 1. So Y parameters are short circuit parameters or admittance parameters. So Y parameters or short circuit parameters or admittance parameters are applicable for this series element circuit, and ABCD parameters are also applicable, but Z parameters are not applicable. So correct option is 3. It doesn't have Z parameters, because if port 1 is open circuited, current in port 2 will become 0. If port 2 is open circuited, current in port 1 will become 0. Hence, these Z parameters are not applicable for a series element. So correct option is 3. Next question. The magnitude of the function f of s is given as s square minus 6s plus 8 by s square plus 6s plus 8. So magnitude for this is f of s at s is equal to j omega at s is equal to j omega. Its magnitude is j omega square minus 6j omega plus 8 by j omega square plus 6 j omega plus 8. So the magnitude, its magnitude is 1. So the transfer function represents all pass filter. So for all pass filter, the spectral magnitude response is unity over all the frequencies. That is, it passes all the frequencies equally in gain, but produces phase shift between input and output. All pass filter provides flat amplitude response for all frequency signals. Flat amplitude response for all the frequency signals. Hence, the magnitude of all pass filter is independent of frequency. So magnitude is independent of frequency. First option is a correct. And phase response linearly depends on frequency. Magnitude response independent of frequency, and phase response linearly dependent on frequency. First option is a correct one. Next question. The transfer function of RC low pass network. So given RC low pass network, so this is resistor or capacitor C. Let us suppose this is the input voltage Vi, output voltage V0, and current is I. So convert the Laplace transform for this circuit is, so for resistance it is R, for capacitance C is represented in 1 by Cs, and input voltage source current is represented as I of S, and input voltage source is Vi of S, output voltage source is V naught of S. These are Laplace transform for the given circuit. Now the transfer function is a ratio of output voltage to input voltage in Laplace domain. So output voltage is V naught of S is, so from this output voltage V naught of S is 1 by SC into current I of S, and the input voltage VA of S is R plus 1 by SC into current I of S. Now the transfer function is output by input 1 by SC by R plus 1 by SC or CS. So that is 1 by 1 plus R CS. So correct option is 4. Next question. The second order system is given by d square y by dt square plus 12 dy by dt plus 100 y is equal to 0, the damped natural response. So convert this second order differential system into Laplace transform. So s square y of s plus 12s y of s plus 100 y of s is equal to 0. So y of s is s square plus 12s plus 100. So this is a characteristic equation. Compare this characteristic equation with standard second order characteristic equation. So from this omega n square is 100. So omega n natural frequency is 10 radian per second. No, 2 zeta n 2 zeta omega n is 12. From this zeta damping ratio is 0.6. Now damped natural frequency omega d, damped natural frequency omega d is omega n square root of 1 minus zeta square. So on calculation its value is 8 radian per second. So correct option is 4. Next question. A two-port network is terminated by load ZL at output. Then input impedance of terminated two-port network is input impedance of input impedance of a two-port network when output is terminated with. So this is a two-port network when output is terminated with load ZL. What is the input impedance? ZI. The input impedance of two-port network terminated with load ZL in terms of Z parameter is Zin is equal to Z11, and this two-port network has Z parameters Z11, Z12, Z21 and Z22. Now this two-port network is terminated by load impedance ZL, and they asked to calculate the value of source impedance. So that is input impedance Zi. So Zin is Z11 minus Z21 Z12 by Z22 plus ZL. So this is a formula. It can also be represented as delta Z plus Z11 ZL Z22 plus ZL. So this is a formula for input impedance. So either this one or this one. Now if the output port is open circuited, so if ZL is infinity, if output port is open circuited, then input impedance for this two port network is Z11. If the output port is short circuited, so that is ZL is 0, then input impedance becomes delta Z by Z22. So the correct option is 4. When the two port network is terminated with load impedance, then input impedance of the terminated two port network is delta Z plus Z11 ZL by Z22 plus ZL. So correct option is 4. Next question. The resonant frequency of series circuit as shown in the figure. Given the circuit is there, and there are two inductors of 2 Henry and 2 Henry. So inductor say L1 and this is inductor L2 and capacitance is C 2 microfarad. So from this, these two inductors are series opposing. So series opposing coils are two coils connected in series but magnetic fluxes oppose each other. So series opposing means magnetic flux oppose each other. So for this series of coils equivalent impedance is L1 plus L2 minus 2 M. So it is obtained by using dot method. When inductors are connected in series, the magnetic flux of one inductor links with the other inductor. The magnetic coupling between the coils may either increase or decrease the total inductance. The effect of mutual inductance depends upon the coils and their orientation. If the magnetic flux of the coil supports each other, the connection is called series shading. If magnetic fluxes opposes each other, then it is series opposing. It- the direction of the current entering the dot end of the coil determines the polarity of voltage at the dotted end of the coil. If current enters both coils from the dotted end, flux. So here current entering is towards the dot, and for this coil to current is leaving. So if current enters both the coils from the dotted end, so like this. So this is coil 1 and this is coil 1. If dot is placed here, dot is placed here. So in this case, current is entering both the coils from the dotted end. In this case, fluxes aid each other. So flux aid each other. Flux is aiding means then it is series aiding connection. If current enters one coil at the dotted end, so current enters one coil at the dotted end and exits at the other coil. So here current is exiting for the another coil. So in this case, flux oppose each other. So the magnetic flux opposes each other. So it is called series opposing connection. Series aiding and series opposing. So the effect of mutual inductance depends on the distance of the coils and their orientation as well as orientation means either opposing or aiding connection. So for this given circuit, these inductors L1 and L2 are in series opposition. Now for this series circuit at resonance, XL is equal to XC. XL is equal to XC. So mod omega L, XL is mod omega L, L is L equivalent, XL is J omega L. Here it is J omega L equivalent. XC is J omega J by omega C or 1 by minus J by omega C or 1 by J omega C. 1 by J omega C. So from this omega L equivalent is equal to 1 by omega C. Omega square is 1 by L equivalent into C. So from this resonant frequency F is equal to 1 by 2 pi square root of L equivalent into C. So L equivalent is here L equivalent is L1 plus L2 minus 2 times of mutual inductance. Mutual inductance is 1. So that is 4 minus 2, its value is 2 and capacitance is 2 farad. Now frequency F is 1 by 2 pi root LC, that is 2 into 2. Its value is 1 by 4 pi hertz. Frequency F is 1 by 4 pi hertz. So correct option is 1. Next question. In a passive two-port network, open circuit matrix is given. If the input port is interchanged with the output port, then open circuit matrix will be, so passive two-port network. Suppose this is a passive two-port network with parameters ZA, ZB, with resistance ZA, ZB, and ZC. Now this Z parameters are Z11, Z12, Z21, Z22, and its equivalent value is Z11 is ZA plus ZC, 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 ZB plus ZC. Now if Z12 or Z2 in the given network is reciprocal. The resistance value from here is, so for this circuit resistance value is ZA is 8 ohm and Z3 is, sorry, ZB is 3 ohms and ZC is 2 ohms. So this is a circuit. If this input port V1, if port 1 and port 2 are interchanged, so now it will become 3, 8. So this is 3 and this is 8 ohm. As per the question, the circuit ports are interchanged. Then equivalent impedance Z is 5 ohm, 2 ohm. So 3 plus 2, 5, 2 ohm, and then so 2 ohm, 8 plus 2 is 10 ohms. This is a impedance. These are Z parameters. So correct option is 2. Next question. So the inverse Fourier transform of x of j omega is, Fourier transform of x of t is integral minus infinity to infinity x of t e power j omega t dt, e power j omega t dt. So that is x of j omega. So inverse Fourier transform of x of j omega is, inverse Fourier transform of x of j omega will give x of t, small x of t, and its value is 1 by 2 pi integral minus infinity to infinity capital X of j omega e power j omega for minus j here, j omega t d w. So the correct option is 1. Next question. Two port network is represented by the expressions V1 and V2. So from this Z matrix is 24, 8, 8 and 32. So this is equivalent to ZA, ZB, ZC. So for this, so again ZD, ZA plus ZC is 24, ZC is 8, ZB plus ZC is 32. So on calculation, we will get ZA is 16, ZB is 24, and ZC as its value is 8. So ZC is 8. So correct option is 1, 16 ZA. So ZB is 24 and ZC is 8. Next question. Impulse response of first order system is described by the differential equation. So for first order system, dy by dx plus 4y is u of t. So consider this u of t as x of t. So let us assume this u of t as x of t, because if we take u of t, so we can assume that it has a step response from signals and systems. Let us assume this is a question. So they ask to find the impulse response. So impulse response means input x of t is delta of t. So that is dy by dt plus 4y is equal to delta of t. Apply Laplace transform on both sides. So s into y of s plus 4 y of s. Laplace transform of delta of t is 1. So therefore y of s is 1 by s plus 4. So apply inverse Laplace transform. So inverse Laplace transform of y of s. So that is small y of t is e power minus 4t. So correct option is 2. Next question. The junction capacitance of the PN junction diode depends on depletion layer in PN junction behaves like a parallel plate capacitor capacitance, and that capacitance is given as Cj is equal to dq by d of difference of V naught minus V, where V naught is a built-in potential or constant potential, V is the bias voltage, and Cj is the junction capacitance, which is voltage variable and dominant under reverse bias conditions. So the correct option is 3. The junction capacitance of PN junction diode depends on both doping concentrations Na and Nd as well as applied voltage V. Applied voltage V, Na and Nd. So correct option is 3. Next question. The general purpose diode is more likely to suffer avalanche breakdown rather than Zener diode because of it is lightly doped. So let us see the comparison of Zener diode and avalanche diode. So avalanche diode, the breakdown is due to collision of accelerated charge carriers with large velocity and kinetic energy, and breakdown is due to in Zener diode heavily applied electric field. So the VI characteristics of Zener diode is more sharp when compared to the VI characteristics of avalanche breakdown. So generally Zener diodes have negative temperature coefficient, and avalanche breakdown is due to positive temperature coefficient. So this avalanche breakdown will occur at more than 6 volts, and Zener breakdown will occur at less than 6 volts. This general purpose diode is more likely to suffer avalanche breakdown rather than Zener breakdown because general purpose diodes are lightly doped. Avalanche breakdown is due to collision of ions having positive temperature coefficient that happens at greater than 6 volts due to low doping concentration. Correct option is 2. Next question. A PN junction is in series with 100 ohm resistor is forward biased so that current of 100 milliampere flows. If the voltage across this combination is instantaneously reversed at 10 volts, reversed to 10 volts at t is equal to 0, the reverse current flow through the diode at t is equal to 0. If t less than 0, so for t less than 0, circuit is like this. So this is the diode. So 100 ohms, voltage source V, forward current is flowing because positive is applied to positive of voltage source is applied to anode and negative voltage source is applied to cathode. So this is a circuit diagram for t less than 0 as per the question, and forward current IF is 100 milliamperes. Next, at t is equal to 0, at t is equal to 0, voltage is reversed. The voltage source is reversed. Now this is diode and resistance R. Now the circuit is in reverse bias. The current will flow like this. The circuit is in reverse bias. When diode is instantaneously switched from forward bias to reverse bias, IF takes some time called reverse recovery time to enter into the reverse bias. During this time interval, diode conducts excessive minority carrier storage. Therefore, at t is equal to 0 plus reverse current, so reverse current IR is 10 by 100, so its value is 100 milliamperes because it takes some time called reverse recovery time to enter into the reverse bias. Instantaneously the current won't become 0, hence correct option is for 100 milliamperes. Next question. The output of half wave rectifier is suitable for. So generally half wave rectifier is a circuit that delivers low output power since half cycle of input is allowed to output, hence rectification efficiency is low. This negative half cycle is clipped at the output. There is no negative half cycle. So hence it delivers low output power as well as rectification efficiency is quite low. This half wave rectifier is rarely used in practice and is never preferred as power supply of an audio circuit because of high ripple factor. As ripple factor is high, hence never used in practice and preferred for power supply. High ripple factor will result in noise at the input of audio signal which will affect the audio quality. Next question. Next point. The DC output power available from a half wave rectifier is not satisfactory to make general power supply Hence, it is used in some applications like battery charging. So 34, the correct option is 2. Next question. The emitter region of PNP junction transistor is more heavily doped than base region, so that the flow across the base region is mainly due to holes. The emitter of PNP transistor is more heavily doped than base, so that current flow across the base region is mainly due to holes. Similarly, the emitter region of for PNP, it is heavily doped, so that current flow across a base is due to holes. Similarly, for NPN transistor, the emitter region of NPN transistor is more heavily doped than base, so that current flow across the base region is mainly due to electrons. For good transistor action, emitter should be heavily doped in comparison with the base, and base width is kept smaller. If the emitter is heavily doped, the base current will be negligible compared to emitter current. Emitter is heavily doped so that it can provide large number of carriers into the base, and base is lightly doped and very thin, hence majority of the charge carriers moves into the collector. Emitter of the transistor is heavily doped because it has to supply charge carriers in a properly biased PNP. Most of the holes are in NPN. Most of the electrons from emitter to pass to the base, to pass through the base to collector. So correct option is 1. Next question. The emitter junction of transistor is forward biased and collector base junction is reversed bias. If the base current is increased, then it is. So given emitter base junction is forward bias and collector base junction is reverse bias. So in this case, the transistor acts in active region. The transistor operates in active region. If the operating point is in active region, the transistor acts like a amplifier. So in active region, the transistor acts like a amplifier. For an amplifier, if input current, base current is increased, the output current, that is collector current, obviously increases. So collector current will increase. So here it is an amplifier. If input current increases, output current also increases. Next question. For BJT under saturation, that is HFE, forward current gain into base current greater than or equal to collector current, or DC current gain beta AB greater than or equal to collector current. Second option is that IC less than beta IB under saturation. Next question. The Schottky diode is clamped. Schottky diode clamp is used along with the switching BJT. A Schottky diode clamp is used along with the switching BJT for reducing the switching time. Schottky diode has very low, because Schottky diode has very low switching times. So correct option is 1. So for reducing the switching time, to increase the speed of operation, Schottky diode is clamped to the transistor. Next question. For an N channel JFET having drain source voltage constant, if gate source voltage is increased, the pinch off would occur for small values of drain current. So pinch off would occur for small values of drain current. Option 4. For an N-channel JFET having drain source voltage constant, if gate source voltage is increased more negative, then pinch off would occur at small value of drain current. Next question. The output characteristics of enhancement mode MOSFET has. So given the circuit diagram has given this figure shows the VI characteristics of enhancement mode MOSFET. So this mode MOSFET operates in three regions: linear region or ohmic region. So this is linear region or ohmic region of operation, and then saturation region, and then cutoff region. Three regions of operation. One is linear region or ohmic region, saturation region, as well as cutoff region. So saturation is a region to the left side of the pinch off locus. So this saturation is a sorry linear region or ohmic region. It is a place left side of the pinch off locus. So this is left side of the pinch off locus, which is linear region or ohmic region. Next, saturation region is a region right side of the pinch off locus. So this region is saturation region, and cutoff region is below VGS. So this is cutoff region. Next, MOSFET acts as a voltage variable resistor. MOSFET acts as a voltage variable resistor in linear region or ohmic region, and current source as a and constant current source in saturation region, and it acts like a linear switch between cutoff and it acts like a switch between linear region and cutoff region. So between this linear region or ohmic region and cutoff region, it acts like a switch, on switch and off switch. Cutoff region means off switch, linear region means on switch, and as an amplifier in this saturation region. Here it acts like a amplifier. The output VA characteristics of enhancement MOSFET has ohmic region at low voltage followed by saturation region at high voltages. So correct option is 1. Next question. The condition to avoid thermal runaway in the transistor is the rate of heat generated at the collector junction, rate of heat generated dou Pc, that is dou Pc by dou Tj. Rate of heat generated at the collector junction should be less than or equal to rate of heat dissipated dou Pd by dou Tj. Rate of heat dissipated. So correct option is, or it can also be written as dou Pc by dou Tj less than or equal to 1 by theta. So both 1 and 2 are the correct options. So correct option is 3. Condition to avoid thermal runaway is rate of heat generated at the collector junction is less than or equal to the rate at which it is heat dissipated. Next, the negative swing starts clipping first when Q point is. The negative part of the output signal in a transistor circuit starts clipping if Q point of the circuit moves towards the saturation region. Suppose if Q point is close to saturation region, the negative part of output signal is clipped off, and the positive part of output signal in the transistor circuit starts clipping if Q point is moves towards the cutoff region. Suppose if Q point is close to cutoff region or if Q point is in the cutoff region, the positive half cycle of the input signal is clipped off at the output. The maximum peak to peak output voltage swing is obtained when Q point of the circuit is located at the center of the load. So that is circuit Q point of the amplifier is selected in the middle of middle of active region because to produce a distortionless output. So correct option is 2. It is near to the saturation region, then negative output starts clipping. In an RC coupled amplifier is assumed to have single pole low frequency transfer function, and the maximum lower cutoff frequency allowed for amplifier to pass 50 Hz square wave with no more than 10% tilt is. So the definition for tilt or sage is defined as decay in the output signal from t is equal to 0 to t is equal to t naught by 2 when input maintains constant amplitude level. So tilt is given as delta V naught is equal to Vm t naught by 2 RC. So percentage tilt or fractional tilt is delta Vm by Vm or t naught by 2 RC. So percentage tilt it is given as delta V naught by Vm into 100 or T naught by 2 RC, 2 RC resistance and capacitance into 100 percentage. And then if T is a signal here it is T naught is signal time period, and delta V naught decrease in output, F naught is frequency, delta V naught is decrease in output voltage, decrease in output, F naught is signal frequency. From this lower cutoff frequency, FL for the circuit is 1 by 2 pi RC. So from this we can write this fractional tilt as or percentage tilt as T naught by 2 RC into 100 or pi FL by F naught into 100. So this is the formula for percentage tilt. So f naught here is 50 megahertz, sorry, 50 hertz. So percentage tilt is 10%. So percentage tilt is 10%. So 10 is equal to pi fl lower cutoff frequency by f naught, that is 50 into 100. So its value is, therefore fl is equal to 1.59 hertz. Lower cutoff frequency is 1.59 hertz. Next question. So Zin is HIE minus numerator by denominator. So this input impedance Zin is equal to HI input impedance minus HR, HL, HF by 1 plus HO ZL. So option 1 can also be written as HI minus HF HR HO plus YL. So YL is 1 by ZL. Load admittance, ZL is load impedance, YL is load admittance. So input impedance ZI is independent. Input impedance ZI is a function of load impedance ZL. Is a function of load impedance ZL. So correct option is 1. Next question. So DC coupled amplifier is especially suited for amplifying. So correct option is 4. Changes in DC voltages. In multi-stage amplifier, DC coupling is especially suited for amplifying changes in DC voltages. Next question. One of the following effects with negative feedback in amplifiers. The negative feedback in amplifiers decreases gain, increases bandwidth, decreases noise. Next, stability increases, as well as nonlinear distortion decreases. Nonlinear distortion or harmonic distortion, nonlinear distortion or harmonic distortion decreases. Next, from this correct option is 2, decreases harmonic distortion and nonlinear distortion and increases the bandwidth. So correct options are 2 as well as 3. These are the correct options for this question 46.